right, boys and girls, so today's math lesson is lesson 118, identifying intersecting and perpendicular lines. But before we begin the lesson, I want you to take out Class Fact Practice Sheet 118A. Lay it to the side for just a minute. We're going to review our 2 times table before we take this because it will be timed for 3 minutes. So I'm going to hold up these cards and pause for a minute, and then I'll say the answer, but you try to beat me to the answer. All right, so here we go. 18. 8. 14. 6. 10. 4. 16. 2. 12. 0. Good job. Now, take these papers. Now, put your pencils down. I want your tracking finger only. We are going to read each row, each problem together with the answer, and then we will time the work. All right, so tracking finger only, and say it together with me. Row 1. 2 times 2 equals 4. 2 times 5 equals 10. 2 times 8 equals 16. 2 times 1 equals 2. 2 times 6 equals 12. 2 times 3 equals 6. 2 times 9 equals 18. 2 times 0 equals 0. 2 times 7 equals 14. 2 times 4 equals 8. Row 3. 2 times 8 equals 16. 2 times 3 equals 6. 2 times 2 equals 4. 2 times 5 equals 10. 2 times 0 equals 0. Row 4. 2 times 6 equals 12. 2 times 1 equals 2. 2 times 9 equals 18. 2 times 4 equals 8. 2 times 7 equals 14. 2 times 3 equals 6. 2 times 5 equals 10. 2 times 9 equals 18. 2 times 6 equals 12. 2 times 2 equals 4. Good job. Now, get your pencils out. You're going to time yourself for 3 minutes. Have a colored pencil or crayon to the side so that if the timer goes off, you will keep working in your colored pencil or crayon. So now is the time to turn off the video. Do the front side, you get 3 minutes, and the back side for 3 minutes. And then come back on and we will continue our lesson. So go ahead and start that. All right. So right before our long break, not necessarily break, but the last time we were together in this classroom, we were talking about parallel lines and line segments. And when we think about parallel lines, you might think of railroad tracks. Even the word has a clue in it. You have the 2 L's that are side by side, the same distance apart. And so that is what parallel lines are. That is something that we know for sure about them. They will never meet, and they will always stay the same distance apart. So as you can see on this geoboard, I've created a set of parallel lines. They are the same distance apart, no matter if I turn them this way or that way or this way. They're the same distance apart, and if I continue the line straight out, they would never meet. Now today you're going to learn about line segments that meet in a special way. So now I want you to look at my geoboard and see what I've created, whether I hold it this way or whether I hold it this way. There is a point on this geoboard where the 2 line segments meet. And mathematicians call this intersection. The intersection of the line segments. They are intersecting lines. That is why we say that when 2 streets meet, we have an intersection. And there are special types of intersecting lines. So I want you to look at the board. And I also want you to have handy your little sheet that has the little geo boards on them. I know my geo boards are funner than those, but we will work with those. So I want you to look up here at the board. So when two line segments intersect like these do, we call them perpendicular line segments, all right? So we see at first we have a point of intersection right here. Now on your number 1 geo board, go ahead and create this here. Go ahead and make those two lines and go ahead and put a dot at the point of intersection. These are where the two lines intersect or meet. Just like it said, sometimes you come up to a street and you have two streets that intersect or meet, and you have a stoplight or a stop sign or something like that. So when the two line segments intersect like these do, we call them perpendicular line segments. Now, in order for a line segment to be perpendicular, it has to form one right angle. And remember, it's been a couple weeks ago that we talked about it. A right angle is kind of like an L shape. And the way you can even test to see if the intersecting lines have a right angle is you can take a sheet of paper and you can try to lay the corner, the edge of the paper, and see if you have a perpendicular line. So look right here. Can I lay it here? Is this a perpendicular line segment? Yes, it is. That corner fits in there perfectly. Also, if I do it right here, do you see how the corner meets perfectly? And I could do it on all four sides, and you see I have 4 right angles. So just take your pencil and draw at least one. This is the little symbol that you draw to show that I have a right angle. And like I said, on this one you actually have 4 different right angles. Now look at this line segment here. It's very similar, the intersecting line segment that I did on my geo board is right here. And so the point of intersection, go ahead and draw that on your paper. The point of intersection is right here. This is where the two lines meet. Now on your paper, show me the 2 right angles. And remember, if you wanted to test to find the perpendicular line segment, you can hold a sheet of paper just like this. And this is for now just a good visual because this is just new learning for you. But do you see how this corner fits perfectly into that line segment here, the intersecting line segment? So I could draw my little symbol. There's one right angle and here is another right angle. So this has actually it has 2 right angles, 2 perpendicular line segments here. All right, so now look at this one here. Go ahead and create this one on your geo board. And the point of intersection is right down here. Do you see where these lines meet? All right, so a special type of intersecting line segment we have right here are the perpendicular line segments. And let's find those using a sheet of paper again. Does it fit there? Oh yeah, do you see the L shape that it makes, the right angle? Makes the right angle here, and here, and here. Do you see that, boys and girls? All right, so you can draw your right angles here. You have 4 of them. All right, now look at the shape down here. Your 2 intersecting lines here. go ahead and do that on number 4 of your perpendicular line segment sheet. And then draw a dot here right at the point of intersection. So this is where the 2 lines meet. And let's find our perpendicular lines. You can take a sheet of paper and do that. A lot of you can just visually see it now. I'm using this red against the white background so you can see how it forms. Do you see this L shape or this right angle? And there's 4 places that it does that. Do you see that? Now you may even draw these on your paper that you have. And then finally, now you don't have a number 5, but finally you see this shape, and the point of intersection here, put your little dot here, this is where your 2 line segments meet, your intersecting lines, they meet right there. And so if we were to identify the perpendicular line, wow, this is like a big L, this is an easy one that you can see that right angle right here. So if you put your paper here, you see that perpendicular line right here. And you can go, well, you don't have a number 5 to draw it, but I've shown you there on the board. So, anytime you need to check and make sure that line segments are perpendicular, you can always use the corner of a piece of paper. All right, now, we're going to go ahead and hopefully when we get back together soon, we can use our geo boards. They're much funner than a piece of paper, and we will do more on intersecting lines and perpendicular line segments. So you may put those to the side. This was just a brief introduction to that. And then get your sheet out. That is your Guided Class Practice 118A. And we're going to look at the front side together. So get those out, please. And I'm going to erase this. And we're going to do some of these together so that the back side will be much easier for you. All right. So get your ruler. The first thing you're going to do is draw your 9 centimeter line segment. So be careful that you're not using inches but centimeters. And then you're going to measure the date, the line segment there for the date. Remember, the line segment has a starting point and an ending point. All right, now look at number 1. Get your trackers out. The question says, or the problem says, pencils are sold in packages of 3. Mrs. Conlon bought 7 packages of pencils. Draw a picture to show the packages of pencils. Now let's first of all answer the question, what type of story problem is this? We've learned 3 different kinds, some and some more, some went away, and equal groups. What kind do you think this story problem is? You are correct. It's actually a story of equal groups. So you will write that in that first blank. Equal groups. Now you're supposed to draw a picture in the space provided. Now let's look at the problem again. It says there are 7 packages. Let's draw the packages first. 1, 2, 3, 4, 5, 6, 7. Now, it says in each package there are 3 pencils, right? So we're going to have to draw pencils, 3 pencils in each package. So let's do that now. So I've got my 7 packages. I'm putting 3 pencils in each package, because this is a story problem about equal groups, because each group has the same number in each group. That's why it's called equal groups. So we've got our picture drawn. Now, what would our number sentence be? So think about your number sentence. How many cartons or packages of pencils do we have? 1, 2, 3, 4, 5, 6, 7. We have 7 packages. And how many pencils are in each package? 3 pencils. We can put a P. So how many pencils would that be? Because it says, how many pencils did she buy? So we want to know the number of pencils. So let's think about our 3 song that we learned. 3, 6, 9, 12, 15, 18, 21. So 7 times 3 equals 21 pencils. And then your answer is, you write it out again, 21 pencils. All right, so this is number 1, so you should get it completely correct because we did it together. Now look at number 2. It says circle the perpendicular line segments. I'm going to erase this one for now. And you have something that looks like this, 2 lines that look like that. A line that looks like this. And it says circle the perpendicular line segments. Now remember, perpendicular line segments have to be intersecting lines, and they have to form a right angle where they meet. So if I'm still not real familiar about perpendicular line segments, I may use my piece of paper. Well, right off the bat, I know, what are these lines called? Remember, I did have the word written right here. Parallel. These lines don't ever meet, so we don't circle that one. What about this line? Could I take a piece of paper and make a right angle here? Oh, yes, I could. And on that side too. So yeah, I'm going to circle this one. All right. What about this one here? Let's look and see. Oh, yes. I sure could. I'm going to circle this one. Look at this next one. Does my corner make an L shape here? No. Look how wide that is. That does not make my little L shape. So no, I would not circle that one. What about this one? Yep. So there you go. Those 3 would be the correct answer. Now, look at number 3. We learned about area last week, I think, when we took, or maybe the week right before Easter, where we took our little tiles and we laid them out in different shapes, and we counted the number of 1-inch tiles, because the area is the number inside, the square feet inside, the square inches inside. In our case, it was the number of tiles inside. And remember, perimeter is distance around the rim. That's when we add all the sides together, like if we wanted to put a fence around an area, or if we wanted to put a border around the chalkboard, we would look for perimeter. But the area is what's inside. So if you look at this shape here, and we have the little square color tiles, the way you would actually find the area is you count the number of units inside. So let's look. We have 1, 2, 3, 4, 5, 6, 7, 8. So our answer would be area equals 8 square units. Now look what number 3 says. It says color 1 square. So I'm going to just choose any square and color. But look at what the next question asks. What fractional part of the rectangle is colored? I've colored one piece, and I know there's 8 total pieces. So how would I write my fraction? So the answer to that question would be 1 of 8 pieces is colored. So my fraction would be 1/8. That is number 3. This was number 2. All right, now look at number 4. It says round each number to the nearest 10. And we did this many lessons ago. So they've given you 3 different numbers, and you have to round it to the closest 10. And sometimes the easiest way to do that is to think about what 10 is on each side. Would you round down to 70, or would you round up to 80? So down or up. And the number that determines that is this number right here. Remember, if it's 5 or above, we go to the next highest 10. And if it's 4 or below, we round down to the lower 10. So looking at 78, what would we round to? We would round up to 80. Now look at number 13. We have 10 on one side and 20 on one side, but this is the number that's the key to tell us. Is it closer to 10 or 20? Is the nearest 10 10 or is it 20? You're correct. It's actually 10. And then look at this number. We're between 20 and 30. Would I round down to 20 or do I round up to 30? Yes, I round up to 30. Now, boys and girls, when you're filling out your math sheets, please write neatly. Some of you are rushing through and your numbers are sloppy and it's hard reading them. So please take your time to do them neatly. Do your work as unto the Lord. Now look at number 5. This was number 4. Number 5 says circle all the geometric solids that have at least one point, or the fancy word vertex. And so we have looked at all kinds of geometric solids, and I'm going to hold them up in a minute so that you can tell me which ones we will circle. And a point, at least one point or vertex. So let's look at the pyramid first. Here's the pyramid. Do you see at least one point or vertex in the pyramid? Yes, you do. So we will circle that one. All right, what about the cylinder? Here's my cylinder. Do you see a point? A vertex here? No, we don't, do we? What about a cone? Do you see a point or vertex here? Yes, you do. So we will circle the cone, not the cylinder. What about a sphere? Is there a point? No, there's not. And lastly, what about a cube? Do you see a point or vertex here? Yes, we do, right? All right, so we circle that one as well. So that's what number 5 looks like. Now, let's look at number 6. We have 62 minus 38. And it's really important that we think about our little poem here. More on the top? No need to stop. Is there more on the top? No, there's actually more on the floor. So what does it say? More on the floor? Go next door and get 10 more. So I have to go next door, borrow 10 from this guy, bring it back over. Now I am ready to subtract. 12 minus 8 is what? Correct, 4. 5 minus 3 is 2. Answer is 24. Now we have an addition problem. 68 plus 37 plus 25. 8 and 7 is 15. What is 15 plus 5? 20. You put your 0 down. You carry this 2 and circle it because we don't want to forget we have to add it. 2 plus 6 is 8. 8 plus 3? 9, 10, 11. Plus 2? 12. 13. 130 is my answer there. Now, look at this next one. We have $2.93 plus $3.78. Now remember how important it is to bring that decimal down and that dollar sign down so I don't forget it. And I have to line my columns up so that my answer is correct. 3 plus 8 is 11. Carry that 1, circle here so I know to add. 9 plus 1 is 10. Plus 7, 17, you're right. 7 down. Carry that 1, don't forget it. 1 plus 2 is 3. 3 plus 3 is 6. There's your answer. Now these last two are pretty easy because we know when you multiply a number times 10, you write the number down, and how many zeros do you add? Just 1. 8 times 10 is 80. Look at this one. 3 times 100, you write this number down. How many zeros do I have? I have 2. 3 times 100 is 300. Now, boys and girls, you should have 100% on side A. And now it's your turn to side B. Have a good rest of your day. I love you.